Now we want to look at what you probably have heard about, things we call stationary points. Now the idea of stationary points is that we want to look at what happens at for our gradient function when the first derivative, or the gradient function, is equal to 0, because certain things start to happen. We know we get stationary points, we know that the curve's neither rising nor falling, and what we want to do is start to class those points, put them in some sort of category, and we've got three categories we can do that: maximum, minimum, or horizontal points of inflection. So what do we mean there? Well, if we've got a stationary point where the curve is rising beforehand, so the derivative is positive, then it's 0, and then it falls, we get this type of point here. So that's what our curve looks like, and we call that a maximum turning point. So it rises and then it falls. So what's basically happening is that we get the values decrease after the turning point. When we've got a situation where the curve falls and then is stationary and then rises, we get a situation where we get a minimum turning point. So the curve falls, stops, and then rises again. And after this turning point, it starts to increase. The curve is increasing there. So it's going from a case where it's decreasing to increasing. When it's maximum, it's increasing and then decreasing. So, and then if we get this situation where it rises, then it's stationary, but then it rises again, the curve starts to look like this. And we've seen a few of these types of ones. It's what we get in what we call an inflection point. Now, it's getting an inflection point because it is changing concavity there. So you can see it's concave down, the concave up. So a stationary point where it changes concavity is called a point of inflection. And this, in the case where it does, where it's got a gradient there, it's a horizontal point of inflection. Notice the concavity of those two doesn't change, but for a horizontal point of inflection it does. And here's one where the curve falls, it's stationary, and then it falls again. So that's where we get points of inflection, horizontal points of inflection. So looking at what the graphs there would look like. So a maximum turning point, the curve rises and then it falls. So here we increases. It gets to a point where it's stationary and the gradient's 0, and then it gets a negative gradient. So our graph at that point would look like that. So turning point there, positive before, negative after. And minimum's the opposite. So the curve falls, it's stationary, and then rises again. So it decreases, gets our minimum turning point, and then increases. So a negative gradient, 0, and then a positive gradient there. So, and then the horizontal point of inflection, you get to see the curve rises, stops, and rises again, increases, horizontal, increases. So a graph of it will look like that. And then we get the gradient falling, 0, then falling, so 0, negative, decreasing, stationary, decreasing. And our graph of the gradient would give us negative values before and after the stationary point. So that's how we class our 3 points, our points into 3 categories: a maximum turning point, minimum turning point, or a horizontal point of inflection.